Question 1 says, write an example of a column matrix. What's a column matrix? How many columns? 1. Just one column, and columns are horizontal or vertical? They're vertical. So this would be an example of a column matrix, right?
Yeah.
I can put any numbers in there. It does not matter what I put. What would be a row matrix?
3 by 3. Or whenever it's long or like.
Yep, just one row, right?
Yeah.
Okay. No more than one. Cool. An example of a 3 by 3. Pretty straightforward, right? 3 rows by 3 columns. It does not matter what I put in that. I'm just going to put a bunch of zeros. It doesn't matter what you put. Put whatever you want. Okay, when we are multiplying a matrix with dimensions 1 by 2 to a matrix with dimensions 2 by 3, the product would have what dimensions? What'd you say?
1/3.
Yep, 1 by 3. So we write them in order like this. We see that these 2's match, which means yes, we can multiply these two. And our resulting matrix is going to be a 1 by 3, the outside numbers. Okay, A24 represents which element in the following matrix? What does that mean? If I give you A, which we said means element, what does it mean if I give you a number, a 2-digit number right there? Rows, then columns, so row 2, column 4, which would be what? -24. Yep. If I go to row 2 and column 4, it would be -24. So my answer is just -24. Any questions on that? No, ma'am? Cool. All right, perform the following operations. Number 5. What does it mean when I've got a number on the outside?
You just like.
What do I do?
Multiply it.
Multiply it, right? We distribute is another word for that, okay? That's what we call a scalar value. My answer is going to have what dimensions? A 2 by 4, okay? The same as what I'm multiplying to. So 2 rows by 4 columns. I'm just going to multiply each of those numbers on the inside by 6. So I should get going across 12, 24, -18, 0, 24, 12, 12, 0, right? That's it. That is all. Any questions on that? Okay. Next one, number 6, what operation are we doing? Addition. And when we are adding two matrices, what's the one thing that has to be the same? 2 things, actually. They have to have the same amount of, rows and columns. Okay, do these. Do both of these matrices have the same amount of rows, same amount of columns? So my answer is also going to have the same amount of rows, same amount of columns, right? A 2 by 4. And if I'm adding, I just add the individual elements, right? So if I start with element 1, 1, 12 plus -2 would be 10. 24 plus 2, -18 plus -5. Be careful with your negatives. Perfect. -23. 0 plus -1. Good. 24 plus -1. 12 plus 6. 12 plus -1. And 0 plus 5. Here we go. That's it. Okay. Any questions on that? Are we good to move on? Okay, so that brings us to a good point. Yeah, number 7. Can we do 7? Why not? Not the same amount of rows, not the same amount of columns, right? So what do we call it? Undefined. Good. This is undefined. Cannot do that. What about number 8?
Subtract.
Subtraction. Are those the same size? Yep. 15 minus negative 4. 19. Be careful with your negatives. Good. 12 minus 11. 1. And negative 18 minus 9. Negative 27. Good. That's it for that one. Any questions on that? Cool. Number 9. Ooh, what operations happen here? This is multiplication. This is not addition or subtraction. So with multiplication, do they have to be the exact same size? No. What is the rule for multiplication? We just did it in number 3. The dimensions. Write the dimensions at the top, right? Then we see, do the 2 in the middle match? And if so, our answer is going to be the 2 on the outside, right? Okay, so looking at the first one, what are the dimensions on that? A 3 by 3. Cool. Second one, a 2 by 3, 2 rows by 3 columns. Perfect. Do my center 2 numbers match? Are these the same? No. So what do we call this? Undefined. Can't do it. Okay, you'll save yourself a lot of time if you write those dimensions at the top in the beginning and you don't just automatically think you can do all of them. Because I will say there's going to be one on the test that you can't do. But make sure you pick the right one. Number 10, same deal, right? Still multiplying. So we need to write our dimensions at the top. On the first one, dimensions of that are what? A 4 by 2 and a 2 by 2. Are my center 2 numbers the same? Yes. So my answer is going to be a 4 by 2, which means 4 rows by 2 columns, right? Cool. Okay. When we are multiplying, again, it always goes rows and then columns, correct? Yes. So for that first matrix there, do I care about its rows or its columns? Rows, just the rows. So I need to divide that into rows. I would use your pencil, draw lines. If you want to use a highlighter, highlight. If you want to label to the side, row 1, row 2, row 3, row 4, that's totally fine with me too. Do the same on your answer. Okay. The next matrix, what do I care about there? The rows or the columns? Columns. So separate those into columns. Same thing with your answer. And again, you don't have to label these rows with R1, R2, C1, C2, all that if you don't want to. But I've found that it is kind of helpful to some of you. So feel free to if you want. Any questions so far? Okay, so starting with that first element that we are finding, it's in row 1, column 1, right? So I go to row 1, I go to column 1, and I multiply first term times first term, so 2 times negative 1 is negative 2 plus second term times second term. What's 0 times 1? 0. What is negative 2 plus 0? Perfect. That goes right there. Okay, going across. So I'm going to stay up there in row 1, but now I'm going to column 2. So first term is 2 times first term is negative 1, which is negative 2 plus 0 times negative 1. 0. So again, we get negative 2. I'm now done with that first row, right? So feel free to cross off the first row if you'd like to. Okay. Row 2, column 1, first term, negative 4 times negative 1. Positive 4 plus negative 3 times 1. Negative 3, which is 1. And column 2, negative 4 times negative 1. Positive 4 again, right? And negative 3 times negative 1. Positive 3. 4 plus 3 is 7, and we're done with row 2. All right. Moving right along to row 3. First term times first term, so 0 times negative 1 is 0 plus 2 times 1, 2, so 0 plus 2 is 2. 0 times negative 1, 0, and 2 times negative 1, so 0 plus negative 2, negative 2. Done with row 3, almost done. Negative 5 times, what should I multiply first? Yep, negative 5 times negative 1 is plus 0 times 1, which is 0. Good. And that is 5. And last but not least, negative 5 times negative 1 is 5 plus 0 times negative 1. So 5 again. How do we feel about that? Easy. We feel better than we did before. Yeah, hopefully. Any questions on that? Okay, cool. Number 11. Okay. So, this one's a little different, right? This one's got one of those what we call scalars, and it's also addition. So what do you think we do first? Just follow order of operations. Yeah, we always distribute first, okay? So we see that negative 4 is being distributed. Is it being distributed to both matrices or just one? Just one. It's just in front of the first one, right? So we need to do that first. So when we distribute that, we're going to end up with a 1 by 3. And what are the numbers going to be in that? Perfect. 12, negative 4, negative 20. And we're still going to add this second one to it. We're not going to change anything about those numbers. So our answer is still going to be a 1 by 3. The first number, 12 plus 5. 17, negative 4 plus 1. Negative 20 plus negative 5. Perfect, that's it. That's your answer. Any questions on that? Okay, number 12. This is what operation? Subtraction. This is subtraction. Okay, so we look, are these the same size? Because we know they have to be for subtraction. Yes, what dimensions would you call these? 3 by 3, so my answer is also going to be a 3 by 3. Okay, we're subtracting them, right? And we see a bunch of variables, and a lot of us get really scared of variables, okay? They're not scary, but we just have to remember we can only combine like terms, okay? So for instance, here we have written x plus y, and we're going to subtract 2x. What would we need to combine there? So if I wrote that up here, x plus y minus 2x. We can combine the x's, right? What is x plus negative 2x? Negative x plus y. Is that as far as I can go? Yeah, because I can't combine a negative x and a y, right? So for my first term, I just put negative x plus y right here. That's it. Okay. Before we keep going, there was one thing that somebody on Friday asked me, and what they said was, if I wanted to go ahead and pretend that this negative was a negative 1 scalar, and go ahead and distribute that negative out to all of those numbers in that second matrix, could I do that and then add the two? Yeah, for sure, okay? If you think that that's easier, do that, okay? If you don't do that, though, just make sure we know we're subtracting. Okay, so make sure we know that that second, or that term in that second matrix is going to be subtracted. Okay, so I'm going to go kind of quick through the others, just because we should know how to combine like terms by now. So if we do negative y minus y, negative 2y, x minus 3x, negative 2x, 3x minus negative 3. Yep, 3 plus 3x or 3x plus 3, whichever. A minus negative 3 becomes a plus 3, and those are not like terms. Okay? Negative 9 minus 12, negative 21. Negative 2 minus negative 5, 3. Again, use a calculator on these if you need it. Negative 3x minus y. Yep, can't do anything with that. 4 minus x. Negative x plus 4. Or just 4 minus x, whichever. And last but not least, 4y minus x, and then minus 2 plus 3y, okay? This is the only one you have to be extra careful on. Since we are subtracting this whole thing here, this really looks like this. 4y minus x minus 2 plus 3y. Okay, which means that negative has to be distributed there. So 4y minus x minus 2 minus 3y. And if we combine like terms, can we combine any of that?
Yeah.
Just the y. So it just become y minus x minus 2. That was the hardest one. No, there'll just be one. It'll be just the same format as this. Good question. Any questions on number 12? Cool. Number 13, what operation we got here? Multiplication, okay? If two matrices are just written next to each other, that's multiplication. Same thing as if they are written next to each other with a little multiplication dot. Still means the same thing, okay? We look, the dimensions of this first one are 2 by 2, second one, 2 by 2. Can we do it? Yep, and our answer is going to be a 2 by 2. Good. First one, we care about its rows or columns? Rows. And we only have 2 of them, right? Row 1, row 2. If I want to do that in my answer, I can do that as well. Don't have to. If you're getting good at these, you don't have to. Second one, I care about its columns. It's got 2 columns, just like my answer is going to have. So we got column 1, column 2. Okay. 4, my first element here, which is row 1, column 2, or sorry, row 1, column 1. I need to multiply what first? Which is, so, yep, 16x, good. So first term times first term, and then second term times second term. Negative y times 2y, which is, so we'll just do the coefficients first. What's negative 1 times 2? Yep, so minus 2, and then y times y. Y squared. Are those like terms? 16x minus 2y squared? No. So we're just going to keep that whole thing as my first term. Okay. Staying up there on that top row, moving to the second column though. So negative 4 times what? Row 1, column 2. Yeah, negative 4 times 0 is 0 plus negative y times negative 5, which is 5y. So 0 plus 5y is 5y. Done with that first row. And second row, negative 2x times negative 4x. 8x squared, and negative 4 times 2y. negative 8y, are those like terms? Nope. So 8x squared minus 8y. And last but not least, negative 2x times 0. 0 and negative 4 times negative 5. 20. There we go. That is it. Okay? Any questions on that? In my opinion, that's probably the hardest one on the test. Probably 12 and 13. But if you can do that, you're golden. Okay. 14 should be really easy. However, on the senior final, this was probably the most missed question. I think it was because they stressed themselves out learning multiplication and trying to remember all those things. And then the really easy one, they just forgot how easy it was. So don't do that. But when we evaluate determinants, we start in the top left-hand corner, right? Yeah. We start by multiplying down, so 5 times negative 1. Negative 5, and then we subtract, that's the big thing, what we multiply up. So 5 times negative 3 would be negative 15. So we subtract that negative 15, don't add them, okay? So negative 5 minus negative 15 is going to be what? 10. Yep, 2 negatives make a positive, and negative 5 plus 15 is going to be 10. It does. Okay. Any questions on that? Easy points right there. Don't miss number 14. Please don't miss number 14. Multiply down minus multiply up. Okay. Then we've got our 2 bonus questions here, okay? Please at least attempt them, because I did give partial credit for people who at least just set them up, okay? Because they're not that hard. So first one is a 3x3 matrix. It gives you this little hint up here. You just have to know, hey, it looks like they rewrote the first 2 columns to the right, okay? Which is exactly what we do over here. We rewrite first 2 columns. So I would rewrite 0, negative 2, 0, 3, 1, negative 4. Since these are determinants, we start in the top left corner, correct? And we start by multiplying down. So 0 times 1 times 0, 0. 3 times 2 times 0, 0. And negative 3 times negative 2 times negative 4. Negative 24. Yep. Okay, so we add up everything that we are multiplying down. And when we add 0, 0, and negative 24, we should get negative 24, right? Yeah. Now we're going to multiply starting in the bottom left-hand corner. We're going to multiply going up. Do the same thing. 0 times 1 times negative 3. Anytime there's a 0, it's always going to be 0, right? Negative 4 times 2 times 0. 0. And then 0 times negative 2 times 3. 0. Also 0. Okay? Last thing we do with determinants, just like we did with the 2x2, is we always subtract. So the bottom, multiplying to the bottom and multiplying to the top. So negative 24 minus 0. It's just negative 24. That's it. Any questions on that? Okay, I don't know if the test one will have as many zeros. So you might have to do a little bit harder multiplication, but it's totally doable. Okay, cool. Last extra credit one. Again, at least set it up. Even if you don't know what to do after that, okay? You should at least know how to set this up. So if we look here, we see that we've got our little equations here. It tells us what letter is going to be which. I go down here to my equations. A is going to be the first number in front of the x, negative 8. B is going to be 3. C is going to be 9. D is going to be, E is going to be, and F. Perfect. Okay. Okay, now all you gotta do is set up your determinants now that you know those letters. So if I go, first determinant, DET, reading across. Yep, -8, 3, -4, -2. So I just plugged in A, B, D, E. And now we just evaluate. So we start in the top left-hand corner, we multiply going down. -8 times -2, 16 minus -12, and 16 minus -12 is 28. Okay, now we're gonna set up DETX. We're gonna do the same thing. We should already have it done. We plug in CBFE, so 9, 3, -6, -2. Start in the top left-hand corner, 9 times -2, minus, which is going to be 0. And last but not least, DETY. We plug in ACDF, so -8, 9, -4, -6. Start in the top left corner, -8 times -6, minus -4 times 9, -36, and 48 minus -36 is gonna be 84. Okay. Cool. Cool. Any questions on that? So we have our 3 determinant answers, right? We've got 28, 0, and 84. So now we just plug them into our solution right here. So my solution is going to be DETX, which is, what do we find out? 0 divided by determinant, which is 28. And then DETY, which is 84 divided by DET, which is 28. And if we simplify that, 0 divided by 28 is 84 divided by 28. That was a guess. What is 84 divided by 28? Three. Cool. You were right. I thought you were right. So again, guys, first step on that is just to write out A through F, set up your determinants and solve, and then plug into the solution. Any questions on that? We feel good? Feel confident? Okay. Final is next class.